Hello dear student, myself Kanchan Vishramji Kumbalkar. This is your fourth lecture on thermoanalytical method. So let's start. This is the overall syllabus, out of which the introduction of differential thermal method, thermogravimetry, TG and DTG, instrumentation, factor affecting thermograms and application, two applications has been completed. In this lecture, we continuing the point application of thermogravimetry. In previous lecture, we start with the analysis of mixture. This is the application of thermogravimetry. In this lecture, we conclude with the analysis of mixture and study of polymer, which is the important application of thermogravimetry. So let's start. This is the typical thermogram. This is under the application of thermogravimetry. This is the typical thermogram for a calcium oxalate and magnesium oxalate and their mixture. There are three graphs has been observed. First one is the A graph, second one is the B graph, and third one is the C graph. The A graph is typically for that of the calcium oxalate monohydrate. Second, B for that of the magnesium oxalate dihydrate, and the C thermogram is typically for that of the mixture of both, that is calcium oxalate monohydrate and magnesium oxalate dihydrate. Now we discussed it thoroughly. Let's check out first thermogram, that is thermogram A. In thermogram A, which is a graph of which is a thermogram of calcium oxalate monohydrate. In this thermogram, there are the three different regions has been observed. First, second, and third. What are the range of temperature? For a first, it is a 100 to the 250 degrees Celsius. In second, there is a 400 to the 500 degrees Celsius, and the third region is in between the temperature range of 650 to the 850 degrees Celsius. Now, what is the reason? What is the reason behind these three regions? When the calcium oxalate has been get started, when calcium oxalate monohydrate has been get started heated, then it loses water. In between 100 to the 250 degrees Celsius, the water loss takes place, and due to which the calcium oxalate monohydrate get converted into the anhydrous calcium oxalate in this region, and because of the loss of water, there is a weight loss takes place. Above the 250 degrees Celsius and up to the 400 degrees Celsius, there is no any weight loss takes place. There is no any weight loss takes place. So it is a plateau. There is no any weight loss takes place. Above the 400 to the 500 degrees Celsius, above the 400 up to the 500 degrees Celsius, the calcium oxalate, which is under anhydrous condition here, it loses carbon monoxide in a gaseous phase, and this is the weight loss because of the loss of CO in gaseous phase from 400 to the 500 degrees Celsius. Hence, this second region weight loss is in between 400 to the 500 degrees Celsius because of the conversion of calcium oxalate to the calcium carbonate with a loss of calcium monoxide. So this is the 400 to 500 region where the calcium carbonate has been formed with a loss of carbon monoxide as a gas. Further, when we further continuing heating process from 500 to the 650 degrees Celsius, again there is no any weight loss. But from that of the 600 to the up to the 850 degrees Celsius, again there is observe a third region where the weight loss takes place. That is third point. Here the weight loss again takes place. The reason behind this is that there is a formation of, from that of the CaCO3, the formation of calcium oxide, there is a formation of quicklime, that is CaO, with a liberation of CO2. So the third region of weight loss is because of the loss of CO2 gas. So the first region is because of the loss of water molecule. Second region is because of the loss of CO gas, carbon monoxide gas, and third region it is because of the loss of CO2 gas. The temperature ranges are 100 to the 250 degrees Celsius. This is the 400 to the 500 degrees Celsius, and this is the 650 to the 850 degrees Celsius. Now let's focus on the second graph, that is graph B. It is related with that of the magnesium oxalate dihydrate. It is related with magnesium oxalate dihydrate molecule. But it's showing only two regions of weight loss. The magnesium oxalate dihydrate has only two regions of weight loss. First one is this fourth one, and this is fifth one. Only two regions has been shown, only two lines which show that there is a weight loss takes place. What is the reason behind that? When the magnesium oxalate dihydrate is heated in between 100 to the 250 degrees Celsius, when there is a 100 to the 250 degrees Celsius heating takes place, then there is again loss of water molecules takes place. Then that magnesium oxalate dihydrate get converted into here anhydrous magnesium oxalate. Now when you further heated from 400 to the 500 degrees Celsius, the second weight loss takes place. It is because of the loss of carbon monoxide as well as the carbon dioxide. Means the anhydrous magnesium oxalate get further converted into the magnesium oxide with a loss of CO and CO2 simultaneously. So in A there is a weight loss that 100 to the 250 degrees Celsius because of water. Second slot is 400 to the 500 because of the loss of carbon monoxide, and from third region it is observed that there is a 650 to the 850 degrees Celsius because of loss of CO2 gas. In second one, the first region is because of the weight loss takes place because of the loss of water molecule. It get converted into anhydrous condition. Then that anhydrous magnesium oxalate further reacted with that of the 400 and 500 up to the 500 degrees Celsius. There is a weight loss observed because of the loss of CO as well as CO2, carbon monoxide as well as carbon dioxide. Means the magnesium oxalate dihydrate respond up to the 400 to the 500. Above 500 degrees Celsius there is no any weight loss. Now the third point, the third thermogram, that is C thermogram. In this case, this is the typical thermogram graph of mixture of both the oxalate, that is mixture of calcium oxalate monohydrate and magnesium oxalate dihydrate. Now the thermogram for the mixture of these two oxalate would thus show three regions of weight loss: first, second, and this one third. So that has been the numbers has been given, that is 6th, 7th, and 8th. So the third step in this C section, in this C thermogram, the third or the 8th number of step can be because of only due to the loss of CO2 from that of the calcium carbonate, because we mix, in this case in C type we mix both the chemical. We know that the magnesium oxalate dihydrate does not respond above the 400 above the 500 degrees Celsius. Hence above the 500 degrees Celsius means 650 degrees Celsius from 2 up to the 850 degrees Celsius only there is a calcium oxalate monohydrate has been reacted. Means this third curve is only because of the loss of CO2 from that of the calcium carbonate. Hence the amount of calcium present in a mixture can be calculated. Means the total amount of weight loss from that of the CO2 from CaCO3. By comparing it, we can calculate the exact weight of amount of calcium present in this mixture. Similarly, the amount of magnesium in oxalate mixture can be calculated from this step, that is second step, or it can be considered as the seventh number step. From this second step, because in this case the amount of CO due to the calcium carbonate may be subtracted from total observed weight loss, and the remainder is this due to loss of CO2 and CO from anhydrous magnesium oxalate. So this is overall application of thermogravimetry, means identification of the particular, in this case calcium oxalate or calcium percentage, and magnesium salt magnesium oxalate percentage in the mixture can be easily identified by using a thermogram. So this is the overall scenario of that of the thermogram. The first A is a typically thermogram of your calcium oxalate, second one is your magnesium oxalate dihydrate, and third C1 is nothing but a mixture of both. So what are the chemical reactions? Let's check out. Now when we are considering the first thermogram, these are the various reactions. We know that for that of the calcium oxalate monohydrate there are three distinct regions of weight loss: first, second and third. What are the reason behind that? This is the reason, that is when calcium oxalate monohydrate get heated in between 100 to the 250 degrees Celsius, it get converted into the anhydrous calcium oxalate with a loss of water, and the weight loss is because of the loss of water molecules. Second one, there is a from 250 to the 400 degrees Celsius there is no any weight loss, but above the 400 to the 500, in between the 400 to the 500 degrees Celsius, above the 400 degrees Celsius, the calcium anhydrous calcium oxalate get converted into the calcium carbonate with a liberation of carbon monoxide gas. Means the reason behind weight loss is nothing but a carbon monoxide in between the range of temperature 400 to the 500 degrees Celsius. And finally, the third reason of weight loss is because of the conversion of the calcium carbonate into the quicklime, that is calcium oxalate. So the reason behind weight loss is nothing but a loss of CO2 in a gaseous phase. The temperature range, responsible temperature is a 650 degrees Celsius to the 850 degrees Celsius. So means in a thermogram A we observe the three distinct region of weight loss. It is because of, first one is the region because of loss of H2O, second one is the because of loss of CO, and third one is because of that of the loss of CO2 from this range of temperature. Similarly, for that of the thermogram B, in thermogram B, magnesium oxalate dihydrate has only two regions of weight loss. They are because of, first one, the magnesium oxalate dihydrate when heated in between the 100 to the 250 degrees Celsius, it get converted into anhydrous magnesium oxalate with the liberation of water. Means the first weight loss is because of the loss of water molecule gases, and the second weight loss takes place in between the 400 to the 500 degrees Celsius. It is because of when we heating continues and this anhydrous magnesium oxalate get heated, it get converted into the magnesium oxide with a loss of carbon monoxide and with a loss of carbon dioxide. So the first weight loss reason is a loss of H2O, and second weight loss is because of the loss of carbon monoxide as well as carbon dioxide, 1 mole each. So in between 400 to the 500 this reaction has been occurred. So this is explanation regarding that of the third one, that is region for that of the C. Hence, on the behalf of this, we can identify the percentage of magnesium and the percentage of calcium in a mixture of calcium oxalate and magnesium oxalate. Now, the next application is study of polymers. We know that polymers means what? Polymers means there are so many monomers arranged in a various pattern. We know that there are the linear polymer, branch polymer, 3D polymer. So, thermogrametry is an important technique in the study of polymers. Thermogram provide information about the decomposition pattern for a various polymeric preparation. This decomposition pattern are characteristics for each kind of polymer and can be used for identification of purpose. Means during decomposition there are the various thermogram has been observed on the basis of by identifying the pattern of decomposition we can identify the type of polymer. This is the best example for that of the application of study of polymer. Now the next point is the one example on the behalf of which we can identify how to identify the percentage of calcium and magnesium in a mixture of calcium and magnesium oxalate. So this is the one example has been taken. In the thermogrametry analysis of mixture of calcium oxalate and magnesium oxalate, the weight loss was found to be 34.6 mg between 400 to the 500 degrees Celsius and 13.9 mg between the 650 to the 850 degrees Celsius. Find the weight percent of calcium oxalate and magnesium oxalate in the mixture. I suggest you all पेन पेपर लेके बैठिए और try to solve it directly. So क्या दिया है? What has been given in this example? In this example, it has been given that during the 400 to the 500 degree Celsius जो भी वेट लॉस हो रहा है, द वेट लॉस is about 34.6 mg, and in between 650 degrees Celsius to the 850 degrees Celsius it is 13.9 mg. We know that in a reaction we state that 650 to the 850 degrees Celsius only the calcium oxalate monohydrate reaction has been given, in the sense of calcium carbonate get converted into the CaO with a loss of CO2. Means the in between the 600 and 650 degree to the 850 degree Celsius only the weight loss is because of the loss of CO2. Means the CO2 has been lost, and due to which 13.9 gram has been deducted from that of the mass of compound, the mixture both. Now the next point is that in between 400 to the 500 degrees Celsius there are two reactions has been occurred. For a calcium oxalate, as we are discussing, it is a mixture, hence both the reactions simultaneously occur. 650 to the 850 degrees Celsius only one, means calcium carbonate get converted into the CaO with a loss of CO2 takes place. But in a 400 to the 500 temperature range there are two reactions has been occurred. Both anhydrous calcium oxalate get converted into CaCO3 with a loss of carbon monoxide, and again the anhydrous magnesium oxalate get converted into the MgO with a loss of carbon monoxide as well as the carbon dioxide. Means if we are in a simple way, if we are considering the range of temperature 650 to the 850 degrees Celsius, the weight loss is because of only the CO2 from that of the calcium oxalate monohydrate reaction. But if we are considering the 400 to the 500 degrees Celsius range, both calcium oxalate as well as magnesium oxalate both respond, and the weight loss takes place because of the combination of combinedly loss of carbon monoxide as well as the carbon dioxide. So let's start its solution. Now in between the weight 650 डिग्री सेल्सियस टू द 850 डिग्री सेल्सियस पे डिफरेंस कितना आ रहा है 13.9 ग्राम mg, सॉरी 13.9 mg. सो बिफोर 650 डिग्री सेल्सियस और at 650 degrees Celsius, the weight of compound, suppose X. After 850, the 13.9 has been lost. Means the difference between the weight of a compound in between the range of 650 to the 850 degrees Celsius is a 13.9 mg. So that much. What is the reason behind the weight loss in between 650 to the 850 degrees Celsius? It is because of the loss of CO2 from that of the CaCO3. You can check out the chemical reactions which has been previously given. So CO2 loss from that of the calcium carbonate, and that is the basic reason behind the loss of 13.9 mg of compound. But we know that the molecular weight of CO2 is 44 mg. If 44 mg of CO2 has been get liberated from 1 mole of CaCO3, CaCO3 का weight आता है 100 mg, or it can be considered as a 1 millimole of that of the CaCO3. Means अगर एक 1 mole of CO2 has been lost from that of the 1 mole of CaCO3, which has been prepared from that of the 1 mole of calcium oxalate, that is CaC2O3. Means simply 1 mole of, in a first reaction of calcium oxalate, it has been given that the 1 mole of calcium oxalate monohydrate get converted into the 1 mole of calcium oxalate anhydrous, then it get converted into the calcium carbonate 1 mole, and it get again converted into 1 mole of CO2. So if the 44 mg of CO2 is liberated, then what is the initial amount of CaC2O4, that is calcium carbonate anhydrous, that is also its molecular weight, that is 1 mole, that is 128 mg of CaC2O4. Means for 120, if we take a 128 mg of CaC2O4, we get a 44 mg of CO2. But what is the total quantity of CO2 get liberated? That is 13.9 mg. So by taking a cross multiplication, for that of the 128 we get a 44, but 13.9 liberate हुआ है, then what is the total amount of CaC2O4? Hence by cross multiplication we get a 40.4 mg of CaC2O4. Means when we are considering the 13.9 mg of CO2 is liberated, so initially what is the quantity of CaC2O4, calcium oxalate, has been taken is a 40.4 mg. Now we know that 44 mg of CO2, what is 44? It is a molecular weight of, it is a 1 mole of CO2. Molecular weight of CO2, that is 44 mg. CO molecular weight, it's obviously 28, means it's a 1:1 ratio. If 44 mg of CO2 is liberated, then 28 mg of CO can be generated. Means if 13.9 of CO2 has been liberated, then what is the total mg weight of CO? By simply multiplication, cross multiplication, we get a 8.84 mg of CO. Means 8.84 mg of CO has been liberated. Now this is the weight of CO obtained from the decomposition of CaC2O4. So CaC2O4 gives 8.84 CO, and the remaining part is that of the 13.9 is that of the CO2. So this is all about the CaC2O4. Now we want a magnesium oxalate. How much amount of CO and CO2 has been liberated? So in between 400 to 500, what type of reaction has been occurred? The calcium oxalate get converted into the calcium carbonate with a loss of carbon monoxide, and magnesium oxalate get converted into magnesium oxide with a loss of CO and CO2. So in between 400 to 500, both the CO and CO2 gases are responsible for that of the weight loss in both calcium as well as magnesium oxalate. Now as per given, 34.6 gram of weight loss takes place, out of which the 8.84 it is because of the calcium oxalate, so minus it, so we get 25.76 mg. It is the overall weight lost in between the 400 to the 500 degrees Celsius. This much amount of weight is of CO liberated from that of the calcium oxalate. So by minusing it, we get only this much amount of weight which is lost during in between the 400 to the 500 degrees Celsius by magnesium oxalate. So this much amount of weight loss takes place because of the magnesium oxalate. So by calculating this weight correspond to the total weight of CO and CO2 lost from that of the magnesium oxalate. Now we know that what is the total weight CO, what is the total weight of CO? CO is 28 molar and CO2 is a 44 mole or mg, whatever. So total weight of CO and CO2 liberated in a from that of the magnesium oxalate is total 72 mg, means 28 milligram of that of the CO and 44 milligram of that of the CO2. What is 28? 28 is a molar weight of that of the carbon and oxygen total, that is CO, carbon monoxide. Carbon 12 है, oxygen 16 है. So 16 plus 12 it is considered as a 28. So 28 molecular mg of CO2 plus 44 mg of that of the CO2 get a total value of 72 mg. Means MgC2O4 liberate 1 MgO with a liberation of CO, 1 mole of CO and 1 mole of CO2. The total weight of MgC2O4 is 112.7 mg. Means 1 mole of MgC2O4 gives 1 mole of CO as well as 1 mole of CO2, or 112.7 mg of milligram of magnesium oxalate gives a total 72 milligram of mixture of CO and CO2. So if there is a 25.75 milligram of that of the CO and CO2 mixture has been observed, then what is the total amount of MgC2O4 can be calculated. So by simply cross multiplication we get the 40.3 mg of milligram of MgC2O4. So what are the total weight of calcium and magnesium oxalate? This is about weight of calcium oxalate is 40.4 mg and weight of MgC2O4 is a 40.3 mg. Hence weight percentage, obviously 80.7 is the weight, total weight. By adding this, the total weight is 80.7, out of which the 40.4 is the weight of calcium oxalate. It's by multiplying with the 100 we get a percentage. So the percentage of calcium oxalate in a mixture is 50.1 and 49.9 is the weight percentage of magnesium oxalate. So by this method we can identify the percentage of oxalate, calcium as well as magnesium by using a thermogram. So this is the illustration. So up till then, so in next lecture we will start with the derivative thermogrammetry. After that, take care, be safe, thank you.